As savvy algebra students, you might have noticed a pattern here. In 6.1, we asked you to add and subtract polynomials. Right? So we were combining like terms, adding and subtracting, distributing our negatives, everything's good. And then in 6.2, we multiplied, aka, right? Well, first of all, review of chapter 4 multiplication, which is this stuff. And then we did binomials, which we know is FOIL. And then we even went up to trinomials times a trinomial, which wasn't really hard. It was just tedious because you got to keep careful track of everything. So now we got to do the opposite of that. So what we were doing in 6.2 is I would give you factors like x minus 4 times x plus 3 and ask you to multiply them. And you would do that and you'd simplify it and you get x squared minus x minus 12, right? First outers, inners, lasts, and combine. So now I'm going to go backwards. I'm going to give you x squared minus x minus 12 and I want you to find the factors, right? It's sort of like dividing, right? You're trying to figure out what two things would multiply to make this. You can think of it as dividing. The other way to think about it is you might have remembered in school like prime factorization, where you take, a number like 4 and break it down to 2 times 2. That's sort of what you're doing here. You're trying to break down this x squared minus x minus 12 into its component parts, right? What things would multiply to make it. And then also don't forget you can do it for ones like these where 4x squared plus 8x, they both have x and 4 in common. So you can take a 4x out and it leaves you x plus 2. All right, so let's start off with monomial GCF. GCF stands for greatest common factor. So we're going to be looking for the largest common factor, the largest common thing that goes into, multiplies into all of these things. So 24 and 30, what goes into all of them? Well, you can be basic. 1 goes into them, 2 goes into both of them, 3 goes into both of them. 4 divides into 24, but 4 does not go into 30. 5 goes into 30, but doesn't go into 24. 6 goes into both of them. Look at that. 7, no. 8, no. 8 goes into 24, but not 30. 9 doesn't go into either one of them. 10 goes into 30, but not 24. 11, 12. You can see what happens, and so on. 12 doesn't go into both of them. 15 doesn't go into both of them, etc. So the greatest common factor is 6, right? So 1, 2, 3 are common factors. The greatest one is 6. All right, so I can delete all those. All right, then you're going to keep doing it. So you're looking for the biggest number that divides into 12, 15, and 20. Well, okay, 2 goes into 12 and 20, but it doesn't go into 15. 3 goes into 12 and 15, but it doesn't go into 20. 4 goes into 12 and 20, but it doesn't go into 15. 5 goes into 15 and 20, but not in 12, and so on. With this one, what you're going to find is that there's nothing that goes into all of them other than 1. There's no other common number that's common to all 3 of those numbers. It happens. All right, now what about the next part? 9a to the 15 and 15a squared. Ooh, we got some letters here. Okay, start with the numbers. So 9 and 15, what goes into both of them? The biggest thing that goes into both of them. Well, that's easy. That's 3, right? Nothing hard there. Actually, I think I'm going to have to do this one this way. So 3. And then what goes into a squared and a to the 15? Well, that would be a squared, right? Because I could put a squared into a to the 5th, right? A to the 3rd times. And a squared divides into a squared 1 time. So there you go. All right, next. What about 8x to the 7th and 24x to the 5th? All right, well, let's see. 8 and 24, that's obvious. 8, right? 8 goes into 24. And then x to the 5th goes into x to the 5th. 1 time, right? What you're trying to think to yourself is, let me give myself a moment here. What you're trying to think is, can I take x to the 5th over x to the 5th and get something that's either a number or a positive? Yes. And then x to the, oopsie, comma. And then can I do it again for x to the 7th? X to the 7th over x to the 5th goes in x squared time. That works. What you don't want to end up with anything in your denominator. If you end up with anything in the bottom, it's no good. And this works, right? So both of these things are divisible by x to the 5th. X to the 5th divides into x to the 5th 1 time. X to the 5th goes into x to the 7th, x squared times. So it all works out. Of course, I can't leave all of that. So, oops, here. You want to write it down? Pause me for a sec. All right, got to make it go away to fit. All right, now what about the next one? 6, 10, and 15. I don't think anything works for those because 15 is not even, right? If it was just 6 and 10, you could do 2. And if it was just 6 and 15, you could do 3. But it's not going to work on its own. All right, now what about the ends? Well, end of the fourth, right? Because end of the fourth goes into end of the fourth one time. End of the fourth goes into end of the fifth n times. And end of the fourth goes into end of the sixth n squared times. Perfect. All right, now the last one's going to be 4, because 4 goes into 4, 4 goes into 16, 4 goes into 8, 4 divides into 8. When I say goes into, that's what I'm meaning. Now, x, and an x squared, so x is the biggest thing I can do, right? Because x divides into x divides into x divides into x squared. And then I got a y squared, a y cubed, and a y squared. So y squared is as big as I can go for the y's. So the GCF of the monomial, let's write this out, is the GCF, greatest common factor of the coefficients, multiplied by the lowest power of the variable, of each variable, I guess I should say, of each variable present. It's got to be the lowest power because otherwise it won't divide out evenly, and that's the whole point, is that you need to be a factor. Factor means it's going to divide out evenly. If you, let me just go with this one. If I went a to the fifth won't go into a squared. This one only has 2 a's to give, right? I can't go any bigger than that. Right? So I have to go with the lowest power present, and that's a squared. A would work as well, but it's not the greatest common factor. A is a common factor, but not the greatest. Here for this one, x is a common factor, but it's not the biggest one. The biggest one would be x to the fifth. I can't go any bigger than x to the fifth because this term over here only has 5 x's to give. So I can't get any more than that. All right, so now that we know how to find the greatest common factor of monomials, that's what these are, right? These are terms. You can see it, right? Those commas are going to get changed by plus and minus signs in a minute, yes? All right, so now that we know how to do that, how to find that greatest common factor, then we need to factor it out. So the first type of factoring we're going to do is going to be when you factor out your greatest common factor. So you look at your terms and you say, okay, what did those terms have in common? So this one's 20x plus 12y minus 28z. Well, the letters are out because x, y, and z aren't common, so that's done. So you just need to look at your 3 numbers, 20, 12, and 28. The biggest thing that goes into all of them is 4. That would leave you 5x plus 3y minus 7z. Oh no, come back. There it is. I thought I lost it. All right. Done. Now let's move on to the next one. Let's see here. We've got negative 15 n cubed. What is it? Minus 25n squared. Oops, minus 25n squared. Okay. So 15 and 25 are both divisible by 5, but it'd probably be smart on this one to take out a negative 5. That way you've turned both of those negative terms into positive terms. In general, we like our front term, our leading coefficient term, to be positive in the front. All right, so then what about the ends? Well, we go with the lowest power, which is n squared. What will that leave us with? In the first one, we have 3, because 3 times 5 is 15, n, because n squared times n will make us n cubed. Plus, because we vacuumed off the minus, right? By factoring out a minus 5, right, we need to think about minus 5 times what would get us minus 25? Well, that's 5, right? So if I do 5 times negative 5 makes minus 25, and then n squared is n squared. And in case you're missing it, there's something I'm doing mentally here to make this work. You should be able to get every single one of these problems correct, because you can always check yourself. If you know how to distribute, you know how to factor, because you can multiply and check yourself. Negative 5 times positive 3 is minus 15. N squared times n is n to the third. Minus 5 times plus 5 is minus 25. N squared times nothing, well, times 1, if you will, is n squared. There should be no wrong answers in this entire section, much to your dismay, right? All right, so this is 18x cubed. What was it? Minus 30x squared plus 6. I think. All right. Oh, let's see. Numbers. Well, 6, 18, and 30 are all divisible by 6. So that's that. And there's no x's. The reason I can't do any x's is because this term right here doesn't have an x in it. If it was x, then I'd be able to take an x out. But since there is no x in there, I can only take a 6 out. That's it. So it leaves me 3x cubed minus 5x squared plus 1. Oops, I better box that because that's the answer. Okay. Last but not least, oh, let me type this. Hold on. There we go. I got it typed up. All right, so let's start with the numbers. A 16, a 10, and an 8. 16, 10, and 8 are all even, so 2. 4 won't work because 4 doesn't go into 10. So 2, not evenly at least. Right, if it comes out with a decimal, that's no good to us. Then look at your a's. The lowest power you have is the most you could take away, so that's a squared. Right? This middle term only has 2 a's to give, so I can't go any bigger than 2, right? A squared. And then this one, b and a b cubed and a b squared, so b. b is the most I can do because all this first term has to give is 1b. So b, right there. All right, so I'm going to take that away. What will that leave me with? 2 times 8 makes 16. I took away a squared. I divided away a squared. So I need to have 1a left over. That way I would get a cubed if I multiplied it out. And then, let's see, I have a b, and I took it away. So there is no b left. So it's just 8a on that term. Minus 5a, because there were 2, or no, not a, minus 5. There were a squared was right here, and I divided it out and put it in front. So now there's no a squared left. There's no a left. I took them all away. And then there was b cubed. I took 1b away, so that means b squared is right here. And then minus 4. All right, I took out a squared. There were 4 a's here because it's a to the 4th. So that's a squared. And then I took away one of these b's, so there's a b left. Technically, this is the term that's in the highest power, but for this one, we're just going to leave it. And there we go. All right, so that's GCF factoring, taking out the biggest thing you possibly can from all 3 terms, or more terms if there's more, or less. In this case, there were only 2 for this problem. All right, so now what about factoring out a binomial GCF? So let me type this up. Hold on. Okay, there we go. So let's look at this one. So let me just back up a second. If it was 3x times, hold on, let me find a symbol. There you go. 3x times thingamabobber plus 5y times thingamabobber, you would say, oh, hey, they both have that thingamabobber in common, so I could just take whatever the heck that is out, and that'll leave me 3x plus 5y, right? If I could type it. Agreed? All right, well, it's no real difference between that and what we just did, right? So this is 3x times, and then thingamabobber is this, right? 7n plus 2. And then I have plus 5y times that same thing, 7n plus 2. So what I can do is I can say, okay, look, I can take out a 7n plus 2. Oh my gosh, if I could just type 7n plus 2. If I take this off, what's left in this first term? Well, that would be 3x plus 5y. It's no different. It's just that this little thingamabobber has turned into 7n plus 2. And you're done. Right? Okay, so same thing over here for the next one. So they've got a squared times 4b minus 9. Minus 2 times 4b minus 9. So you can see, hopefully, that they have 4b minus 9 in common. So if I vacuum that off, if I factor it out, which is technically dividing. So if I divide this first term by 4b minus 9, what's left? A squared. A squared. And then if I take away 4b minus 9 from the second term, they have minus 2 left. So minus 2. And you're done. It's as simple as that. And we're going to need that technique for factoring by grouping, but I'll do that in the next video. See you then.